I'm excited to present. Now the recording is in progress. Thank you guys for having me. I'm really excited to be here. This is a subject matter that I've been passionate about for a long time, and I'm happy to share that with others. Some of it might be knowledge you guys already have, some of it might be above and beyond. So let's just jump into it. So, as you said, a little bit of background about me. I am the executive director of CCRI. I also chair the Western UP Materials Management Planning Committee, which is an inter-county plan to rewrite our solid waste plans into materials management plans. We'll talk about that in a little bit. And then I was previously a sustainability planner for the city of Fort Collins, Colorado, where I'm from. So yeah, jumping in. So that's who I am. Who is CCRI? CCRI is a 501c3 nonprofit. We're a bunch of volunteers who are passionate about sustainability. We do that through education and outreach. That includes events such as this. We do that through advocacy to our local elected leaders. We do that through expertise and leadership for them. So that's how I am serving on the Western UP Materials Management Planning Committee. I'm there representing CCRI as an environmental interest group. We also host special collection events for certain hard to recycle materials. So if you like what you see here today, I would encourage all of you guys to get involved. Follow us on social media, sign up for our newsletter on our website. We're always looking for volunteers. And if you want to financially contribute to our mission, please visit our website. So continuing on here. So I'm just going to start broadly on recycling and what makes something recyclable. So for something to be generally recyclable, is it a common material people are disposing of? We need some of it to be able to recycle it. Can it be collected and sorted efficiently? Does the technology exist to process it? And then after all of that is accomplished, does it have economic value? At the end of the day, for recycling to work, it is a commodity that is traded on the open market. That value goes up and down, but largely it needs to be positive for any of this to be worth it. So just as we talk about recycling, that's kind of the background of what would make something recycling. So when we just talk about this, some definitions, I kind of talk about single stream a lot. These are our everyday recyclables. A lot of you have probably seen this graphic, but this is all the stuff that we can recycle in our local system here in the Copper Country. So these are your plastic containers, paper, cardboard, your metal containers. And then on there, we have some common stuff that are misconceptions that we don't want to see in there. Plastic bags, cords, chains, electronics, because they have a fire risk, stuff of that nature. We also have what I call hard to recycle items. And that title is a little bit misleading because they're not necessarily hard to recycle physically, but they're an item that needs to be recycled outside of single stream. So examples of this in our state, bottle deposits, scrap metal, tires, batteries, stretchy plastic films. All of these are recyclable materials. They meet that definition we talked about earlier. There's a lot of them. We have the technology to recycle it, and there's a market for it at the end of the day. So this is a list. You can find this on our website, but kind of all the local options for hard to recycle materials in our region. Kind of expanding out as we talk about data. The other things outside of that would be organics. So that's composting. There aren't any really large-scale composters operational yet here in the Keweenaw, but that includes all of our drop-off sites for yard waste, as well as those materials that are sent to landfill. So when we look at that, we start looking at our diversion data. And it was in my old line of work, I became a data person. I didn't naturally start that way, but I realized quickly that the best plans come from having the best data. So one of the roles CCRI fills is we track all of the data that we can. It's hard to get all of it, but as much of the data as that I can get into my system, I want to. So we look at this. This is all the organics that are going to our yard waste drop-off sites, our hard to recycle materials, our single stream recycling, and then what's making its way to landfill. So if we just look at everything here, 2024 are the most recent numbers I have. I'm still waiting on some information to come back for 25 numbers. If you look at the whole system as a whole, we are currently diverting 28.7% of our waste. Now, that is predominantly driven by the yard waste drop-off sites that a lot of the municipalities run. And then also hard to recycle materials, which includes, again, scrap metal, which is really heavy, and that's what drives that number up. Single stream recycling is a pretty small portion of that. If we look at what's called MSW, this is municipal solid waste. In industry jargon, what it really means is kind of your everyday trash and recycling from your businesses and your households, not really counting those industrial waste streams. If we just look at that data, we're recycling about 3.2% of the material we discard. Um, but that looks a little bit differently depending on the municipality that we live in and what services are available to us. So generally what we've learned in the industry is the easier you make it for someone to do the quote unquote right thing, the more likely they are to do it. So if you live in one of the two cities here in Houghton or Hancock, you have curbside recycling every week. And so we see of those households, they average nearly a 16% diversion rate, meaning 16% of those two things that they set out at the curb is recycling, the rest is their trash. Now, if we go down to a little bit less convenient, if you live in a township that has a specific drop-off site for your community, it's a little bit more effort to bring multiple containers there. That diversion rate drops to 10%. Then if you do not live in one of those communities listed, your only option is really to haul into one of the large public transfer stations in the Houghton area. And because of how they track that, we can't really get an accurate diversion rate for that, but it is substantially less. So the reason I'm including all of this is recycling is part of sustainable materials management. But one of my takeaways from that I want you all to have today is that the recycling that we are doing is working. So we talk here, and at the arrows at the bottom, we're starting with that collection at whether that be at your curb or at a drop-off site. Then that recycling is going to a transfer station where it is going to be put in a much larger transportation vehicle, a compacting semi, and it's going to be taken down to Recycle 906, which is our local MRF, which is a materials recovery facility. And that's where they actually sort the materials and then send them off to market. Again, these are a commodity, they're going to get sold, and they're going to get put into someone's manufacturing process. So Recycle 906 is the Marquette County Solid Waste Authority. So they are a nonprofit quasi-governmental organization, and they sort all of the materials that we send them. So if you look at that picture on the left, you can see that is what the trucks that come down from Houghton and Keweenaw County, that's what they drop off. And you can see a whole bunch of recycling in there, but it is all mixed together. And then so we have to have the ability and technology to sort that out into the bales that you see there on the right, that we have our clear HDPE or our natural HDPE there. We have some aluminum cans. We'll have our colored HDPE. We have all our different plastics lines, our metal, our cardboard, and our mixed papers. So those are all sorted separately. And then those are going to be sold out into market. So of the materials that enter Recycle 906's facility, 90% of those materials are able to be sorted and sold on market. That means we have a 10% or a little bit less contamination rate is what we call it. And so what that means is those are items that were too small to make it through the system or were not recyclable in the first place. So, a lot of people want to do the right thing, but they may not know something isn't recyclable. They put that in there. It ultimately has to get sorted out and becomes trash at the end of the day. So, but the fact that 90% of what is entering their door is leaving in a bale, getting sent to a manufacturer is really, really good. So that's something we can all take pride in here. So continuing on, because again, like I said, all of these are being made into new materials. So this is a new graphic that CCRI has been working on with Recycle 906 just to kind of complete the story of where our materials go. So our metals are going to Alter. They're going to process those into raw feedstock that is then ultimately sold to other manufacturers. Our papers are going to Sunoco in Wisconsin, and they're actually turning those into the tubes that you will see inside of different rolls. Whether that be a paper towel roll, toilet paper roll or a larger kind of industrial process roll. Our number one and two's plastics are going to Lower Michigan, where they're actually going to be made into new bottles. So that's bottle to bottle, which we love to see. Our other kind of lower grade, the 3 for 7 plastics, are making its way to Canada, where they're getting made into large, bulky plastics, such as construction barrels. So when you put something in a recycling bin here in the copper country, it's going to go to Recycle 906 in Marquette, get sorted, and these are the manufacturers who are using it in their manufacturing process. So then, if that's what's happening with our recycling, what is going on in our trash? And that was a very question that CCRI sought to answer a couple years ago. So in partnership with Michigan Tech, we did a waste characterization study of all of the materials leaving Houghton and Keweenaw counties heading to landfill. And a waste characterization study is a really fancy way of saying that we took samples of the trash and sorted it. And we took enough that it was statistically valid, and we did it from enough different sectors that we got a representative picture of what's going on. And what we found is that over a quarter of what we are throwing away today could have been recycled. And over a third of what we're throwing away today could have been composted. So if you look at that, that's something that we have the ability, the technology all exists to do. We could easily cut our waste that's leaving the copper country in half if we were able to capture all of those materials. And I will say this is not unique to the copper country. This is in line with data that Eagle has prepared for across the state of Michigan. This is in line with data that the EPA compiles for across the United States. So I see this, and I think that we have a lot of opportunity to do a lot of good. This is scary, maybe a little bit overwhelming, but it also means we have a lot of opportunity to change our environmental footprint on this. So as we start thinking about how we're going to change that is where we kind of get into the idea of the circular economy. And then what's the opposite of that would be the linear economy. So traditionally, we have always looked at this as solid waste management. We extract raw materials from the earth, we process them, we use them to our benefit, and then ultimately we discard them in a landfill where they are buried forever. It is a one-way street from the extraction of the raw commodity from the earth to being buried in a hole where it will never escape back in the earth. So sustainable materials management hopes to shift this perspective and starts recognizing these instead of as wastes, as materials that have value. So with that, I want to introduce the idea of what a life cycle assessment is, because this is how we start to understand the circular economy and where the true value of recycling comes in. So some of you may have seen this before. Some of you may know what an LCA is. We're going to run through a sample one. We're going to talk about an aluminum can there. So this circle starts at that orange arrow at the bottom, but it's our material extraction. So at the beginning, we are going to have to be mining ore out of the earth to make that aluminum can. And there's a whole bunch of environmental impacts of doing that, from, regional water quality issues, emissions from all of the heavy equipment that's using, and just a purely raw land usage. Then that ore needs to be further refined and smelted. There are most likely transportation emissions in between these steps. And then there is a substantial amount of energy usage in the smelting and refinement of that aluminum can. Once it then is sheet aluminum, it can be manufactured into a can quite easily by rolling it, and then it will get shipped to who's ever going to fill it, and then it will get shipped to its end user. We use it. Now, this as a product doesn't really have a lot of emissions from its use, and then it has its end of life disposal. And really right there, we are left with two paths. And the old path under the linear economy is we throw that aluminum can in a hole in the ground where it'll stay forever. The other path in a circular economy is that we can take that aluminum can and we can recycle it, and that aluminum can can be used to make the next aluminum can. And the real benefit of doing this, and why aluminum has always been kind of the poster child of recycling, is that creating an aluminum can, if you start with recycled material, uses 95% less electricity. And when we say 95% less electricity, what we really are meaning there is that's emissions. And so people often think the benefit of recycling is that we are throwing less away in the landfill and that we're saving landfill space. And that can be a good and noble effort, but I think it misses the real benefit of recycling, which is all of these different emissions points across the supply chain farther up, from the extraction of materials, manufacturing, and all the transportation. So the less of that we can have is really the main benefit that we see in this. So that was a fairly simple diagram of a circular economy. And now I'm going to show you an incredibly complex one. And don't worry about memorizing every last detail of this. I will walk you through it. And hopefully we can find some ways where we can plug this into our lives today. So there are really two halves of this. We're going to start with the right side of this. They call it the technical cycle. These are going to be materials that are heavily processed and man-made. So we're thinking about plastics, we're thinking about metals, then those are becoming tools, we're thinking about electronics, cars. These are really the majority of products that we're thinking of in our day-to-day lives, a lot of them. So I'm going to start on that innermost circle with sharing. An easy way we can reduce the number of materials that have to be created in the first place and reduce their environmental impact of doing that is sharing materials. Unless you happen to be a contractor, you may not use your electric drill every single day. And then so most likely, if you're not in that boat where you really rely on it, you're probably going to buy a cheap one, and it's probably not going to last all that long. Where are we better off sharing those kind of resources within our community, whether that be through a tool library, through community groups where, hey, this is an item I don't use all that often, and maybe none of us do together or individually, but collectively we do. Then moving out is the items that we do have is how do we maintain them so that we're prolonging their life. This is stuff as simple as changing the oil on your snowblower every year. It's something we all have to do up here in the copper country, but that item is going to ensure that small engine that is on that snowblower is going to have a much longer life. And what that means is then we aren't going to have to create another one of those prematurely. So maintaining our items, prolonging that life. Then we get to reuse or remanufacturing. So reuse, there's some obvious things. If we're at a point and we don't have a use for something anymore, there's a pretty high likelihood that someone else in our lives or in our community might have a use for that item. So how do we get it to them? That could be something as simple as selling it. We can all sell something on Facebook Marketplace. It could be something as giving it to friends, family, or someone in the community. There's a lot of great buy nothing groups on Facebook these days. It could be donating it to a thrift store where it can be resold. Then there's also the remanufacturing side of this. You'll see this a lot with cell phones where manufacturers will take back your old cell phone, they're going to refurbish it, replace any damaged parts, and then they will resell it. People do this with cars. That's the whole business of used cars. They fix what's wrong with it, they resell it so it can stay in life. So as we move in these circles from the center, as we move out, we're keeping the item intact as much as we can. Ultimately, when we get to that outer ring of recycling, that's when the item is no longer able to be maintained, repaired, and that's when it's going to be broken down for its individual components. And those components hopefully are recycled, and those can go back into the manufacturing spectrum where they can be used as feedstock to make new items. So ultimately, what's missing here? Landfilling. We're not seeing at the end of this that we're wanting to bury those materials in a hole in the earth where they're never accessible again. So hopefully that gives us some ideas of how we could plug this into everyday items we interact with. So jumping to the other half here, biological cycle. So these are our natural materials. There's the really obvious examples we think of: yard waste, our food waste, stuff like that. And then there are some slightly less obvious ones: lumber, or natural textiles, stuff of that nature. So for the cascades, kind of being that center of the circle, this is how can we keep using materials that are already a part of our system? They're already in existence. So a couple examples would be a cotton shirt, assuming it's not done with toxic dyes or any of that, at the end of its life could be shredded. That could be used as stuffing or insulation. And then at the end of that, could still then be composted at the end of that. A wood table could ultimately be chipped, put into a particle board, and then ultimately, when that's no longer useful, be composted. And so this applies to both halves of this side. We need to be able to be designing our products so that they can be, if they're on the biological side, our natural can be composted at the end. And then if they're on the technical side of the cycle, that they can be repairable, that they have a long life. So we can try to keep stuff in use as long as possible, because the longer we're doing that, the less stuff we are consuming. And the consumption upstream is really where a lot of the emissions factors come in. So continuing on the biological cycle, then the things that we do discard, disposing of for composting and anaerobic digestion, basically breaking down those materials and making sure those nutrients are making it back into the cycle. And then that's where we talk about regeneration, farming, and collection. Are we doing this in a way that's not only, I think historically we've looked at a lot, how can we minimize the damage we're doing to the soil? But instead we could flip that and say, how are we actually improving the soil with what we are doing? How are we making sure the nutrients are growing back in there? Especially in an area that doesn't have the best topsoil. This is something very important for us. So I'm going to talk about a couple examples here. And this one is something that is near and dear to my heart as a historic preservationist. And I'm going to talk about historic windows. Whenever I'm given a platform, I like to, because I think it has so many cool benefits and ones that people don't think of. A historic window is really beautifully designed. It is infinitely repairable. It can be taken apart to its individual components perfectly, and any single one of those components can be repaired or replaced. Meaning that, I'm currently sitting in a house that is 100 years older than I am, with its original windows. And if any of them are in poor shape, I can perfectly, with simple tools and simple practices, get them back to new, and they will last hundreds of years to the future. Now, the flip side in this would be I could replace them with newer, and I'm going to say more sustainable, energy efficient windows. And that sounds great as a sustainability professional. But then we look at them and we realize that how they are designed today, they are designed to be easy to manufacture. They're designed to be easy to install. What they are not designed is to be easy to repair. So many times, on a historic window, if the glazing fails, it is meant to be sacrificial and replaced. If the glazing process on a new window fails, that entire window is trash and you need to replace it. So many of the failures of modern windows are reliant on specific proprietary parts that the manufacturer probably doesn't make after 10 years. And if that fails, your only option is to send it to the landfill and buy a new one. And we're doing this to, per the EPA, 10% of our energy loss for a house is through the windows. So we think we're doing this great thing by replacing them because it's more sustainable, but now we are getting trapped in a cycle where we have material that won't last, isn't repairable, and then when it does fail, we're just throwing that one to the landfill, we're buying a new one. So we have all the emissions of that upstream manufacturing process, and then all of the waste going to the landfill, where we can skip the majority of that by preserving and maintaining what we have. Another one that I want to highlight, just because it is so prevalent around us, is just talking about food waste. Food waste, when we did our landfill characterization study, is about 20% of what Houghton and Keweenaw County landfills. The EPA estimates that 30 to 40% of all food produced ultimately will never be eaten and will end up being thrown away. And the majority of that that's being thrown away ends up in a landfill. So if you take that math and you do that, you realize we are producing enough food currently to feed everyone on this planet, but we are wasting a large percentage of that. So the EPA put out this hierarchy of most preferred to least preferred disposal methods for our food. And we don't have to read every detail in it, but I'll break it down into four categories. Our first is feed hungry people. Let's do what we can. If there's food, if you're having a community event and there are leftovers, how can we make sure those are getting sent home with people to share with their friends and family? They're making its way to a food bank. How can we get that food into the mouths of hungry people? Because that's its highest and best use. Secondarily, if we can't do that, can we feed animals with it? Can that be feeding our livestock? Then when we are not able to feed someone who needs it with it or to feed an animal, then that's when we need to be composting it or then putting it for an anaerobic digester. Basically, how can we at least retain those nutrients and make sure we're putting them back into our soils so we can grow more food with them? And then lastly, the thing we don't want to do is we don't want to put it in a landfill where it does no good to anyone. It breaks down, it creates methane gas. A lot of landfills don't have a way of flaring that or capturing that. And then that's just a harmful greenhouse gas that's doing us no good as it's sitting there in the landfill. So just another common example that I'll put out there. Then I wanted to chat a little bit about what's happening in Michigan right now, because this is actually a pretty exciting time to be talking about sustainable materials management in Michigan, where if we were having this conversation 5 years ago, just quite frankly, the geopolitical landscape would look a whole lot different. They have passed updates to the Natural Resources Environmental Protection Act, Part 115, which is where we regulate how we handle solid waste in Michigan. And this started several years ago. And basically what this is doing is this is requiring every single county in Michigan to take their old solid waste plans and convert them into materials management plans, saying, hey, the state has goals that they want to, recycle or compost. They want to divert 30% of their waste by 2029 with a long-term goal of reaching 45% diversion. Right now, we're a little over 20%. I think we're about 25%. But that's very scattered, depending on what region you're in Michigan. So we want to reach these goals. The counties need to start coming up with plans to help the state meet those goals. And so that wasn't an unfunded mandate. The state, through Eagle, is providing funding to all of the counties to do this planning process and to start thinking about this. So the 6 Western UP counties decided they wanted to do this planning process together. For example, here in the Copper Country, 100% of the waste that leaves Keweenaw County travels through Houghton County. It kind of would be awkward to have one of them have this conversation and the other have a conversation in a completely different room. So the 6 Western UP counties are currently meeting and looking at how we can handle our materials more appropriately here in the whole western half of the UP. So a couple reasons why this matters locally. Landfill capacity and tipping fees. While I said landfill capacity is not necessarily the biggest benefit of recycling, we locally use the K&W landfill out towards Ontonagon. It has about 6 years of capacity remaining in its current form. Now, they would be able to permit and design new cells, as they call them, to be added to the landfill, but each cell costs millions of dollars to develop. So in its current iteration, we have about 6 years till that will reach capacity. And how that affects us is it matters in tipping fees. Right now, we pay about $210 per ton to throw trash into the K&W landfill. And I say trash, but we realized from some previous slides that the majority of that is recyclables and compost. So right now it's $210 a ton. If they are going to have to invest millions of dollars into adding new cells to that landfill, most likely we're going to see those costs go up. The other reason it matters locally right now as we go through this planning process is this is our chance to build long-term critical infrastructure. So that can be stuff such as increasing options to dispose of household hazardous waste, which there are currently little to none in the copper country. That can also be looking at large scale commercial composting operations. There are currently two people who are working on developing composting sites in the copper country. Neither of them are online yet. We hope they will, but that's something that certainly this county planning effort could support, as we would love to send materials to them. And then we also need to gain some missing infrastructure for our recycling. So I'm going to go through this slide pretty quickly. This is just the benchmark standards that we have to meet with this planning process, which is curbside recycling for municipalities with more than 5,000 people. We're already meeting that. And drop-off site per 10,000 residents for counties with less than 100,000 people. We are largely already meeting that. And I say this because we could skate by and continue to do the bare legal minimum, but this is also our opportunity to talk to our elected representatives, let them know this is something we care about, and it's our opportunity to go above and beyond with funding to help from the state. So one of the things CCRI is currently advocating on is getting Houghton County to build a transfer station that could serve single stream recycling. Currently, we have a system that is very well designed to take trash from here through a transfer station to the K&W landfill, where we pay $210 a ton. We need that missing element so that we can more easily take recycling from here to Recycle 906, where it is $30 per ton to get rid of our recycling. So this is not only environmentally sustainable, this is a lot more economically sustainable, even counting the fact that Marquette is a lot farther than Greenland. So it's one of the things we're advocating for right now as we go through this planning process. So with that, I am basically at my half hour. So I wanted to give some takeaways for you all. Be mindful of the materials you let into your life and carefully consider how you pass them along. I'll follow that with saying vote with your dollar. When you are looking to buy something, that first one, do I really need this? Could I borrow this? Could I share this, with a friend? Vote with your dollar. Buy stuff that's durable, buy stuff that's repairable, buy stuff used. Be skeptical of anything sustainable that requires you purchase something. So much of sustainability is an absence of purchasing something that you should always be skeptical if being more sustainable is going to require you to purchase a whole lot, because I can tell you that's generally not the case. And then get involved. Talk to your local representatives. Let them know this is something you care about. The counties have all been very involved in this process. They know this is going on. I would say it's 50-50 on them if they care about this and want us to go above and beyond, or if they want us to do the bare minimum. So realize your voice matters and share it with them. So at that, I will turn it over to questions. And again, I just want to say thank you so much for having me. My email address is there on slide. If you guys ever have any questions or anything come up in the future, please absolutely reach out.
Oh, wow. That's a lot to think about, Jonathan.